Okay, so today we're looking at 6.1. 6.1 is about radical expressions and functions. We start off our conversation by looking at square roots. And just really understanding that a square root is the opposite of squaring a number. All right, example, 5 to the power of 2 is just 5 times 5, or in other words, 25. Our notation of a square root is this notation. So, if you are asked to find the following, right? This reads square root of 25, and it means what number taken to the power of 2 equals 25. All right, so that's what that means. So we can say that the square root of 25 equals 5. Once again, because 5 squared is 25. So it's a nice way to check your work. Also, your calculator should have this key on there. You should learn how to use it to check your work. So let's take a look at a few examples. Simplify. Tell you negative square root of 25. So you do this first. That equals 5. You bring down your negative sign. This answer is a negative 5. How about example B? Square root of 81 over 64. So let's think about it. What can we multiply? What number can we multiply to itself to get 81? How about 9? What number can we multiply to itself to get 64? How about 8? We see this does not reduce, so this is our answer. Once again, because 9 over 8 times 9 over 8 equals 81 over 64. And one last example, how about square root of negative 25? This is an example where we do not get a solution or a number does not exist. We say that the square root is not a real number. Once again, there is no number that you can take to the power of 2 to give you negative 25. Because we know a negative times a negative is a positive, and a positive times a positive is a negative. Okay, so continuing on with this square root symbol, we can really generalize this symbol and say that this symbol is called a radical, which is what this section is all about. So the square root symbol, we call it a radical. And an expression with a radical is called a radical expression. Anything inside the radical is called a radicand. So y to the second minus 4 is a radical expression, and y squared minus 4 is the radicand. What we can do is we can evaluate radical functions. Just remember, something that makes a function all of a sudden is the fact that it has f of x. So I can tell you that f of x equals the square root of 3x minus 2. Once again, f of x makes it a function. This notation of that square root makes it a radical, right? So I tell you that our function, f of x equals the square root of 3x minus 2. I want you to find what f of 1 equals. Right, so all we're really doing is replacing x, right? So it's the square root of 3 times 1 minus 2, right? Which is square root of 3 minus 2. 3 times 1 is 3. 3 minus 2, right? Which is the square root of 1. Or in other words, we simplify that and it gives us 1. How about, let's say that's example A. How about example B? I ask you to find f of 5. We do the same thing, right? Replace x with 5. So it's the square root of 3 times 5 minus 2. Right, which is the square root 3 times 5. Well, that's 15 minus 2. And that gives us the square root of 13. As a decimal, it would give us something like 3.606. If I asked to round to the hundreds, it would be 3.61. So making sure you recall how to round. And a last example here. Find f of 0. So once again, all we're doing is just replacing. So it's the square root of 3 times 0 minus 2, which gives us 0 minus 2, or in other words, negative 2. And once again, a negative number inside is not possible, so not a real.